You're welcome to today's class. In this class, we'll be looking at a legendary method of solving power series. Of course, this is the advanced aspect of power series. Okay, before we proceed, I will encourage you to like the video, comment, subscribe, and share with your friends. And as you subscribe, turn on the notification button so that anytime we upload a new video, you can always get notified. Okay, so here before us it's a problem. We thought that 1 minus x raised to the power of 2 bracket y prime prime minus 2xy prime plus 6y equals to what? Equals to 0. Okay, since this equals to 0, we make use of what? Legendre method. So this kind of problem have a general solution we apply to it. And the general solution is y equals to what? Summation n equals 0 to infinity a subscript n x raised to the power of n. Why you see there's a bracket open and there's x written inside, then the bracket is closed. Why this x here simply tells us that y is a function of x. And where is the x? The x is located here. That is, y is a function of what? This x. Okay, so that is what this simply means. So it's still the same thing as I can just write it as y, but what this is telling us is that y is a function of x. Okay, so let's just take note of that. Okay, without wasting our time, let's proceed to the next one. Yeah, if I expand this equation, that is, if I expand this solution, although we are not making use of it here now, if I expand it, I will have something like this. I will have something like this. Although we are not making use of it now, we make use of it towards the ending or the ending part. If I expand, let me just show you how this expansion look like. Now, I said that from this equation, from this solution, we're told that n begin from where? From 0 to where? To infinity. So if I substitute n here into this, anywhere there's n, I will substitute it with what? With 0. If I replace n with 0, so if I replace this with 0, I will have x raised to the power 0, and then I will have a subscript what? 0 here. So x raised to the power 0, it will give me what? 1, because any number or any variable raised to the power of 0 will give me 1. So everything here will become 1. So I'll be left with what? A subscript what? 0. So that was how we arrive at the first one here. A subscript what? 0 here. Just as you can see here. Okay. So if I substitute n, because we're told that n equals to 0 to infinity, so the next one after 0 is 1. So if I replace where there's n with 1, I will have what? A subscript what? I will have a subscript 1 here, and then I will have x raised to the power what? 1 here. So that is how we arrive at this one, a subscript 1 x. Of course, you know that x here, it has a power of what? It has a power of 1. So if I substitute n to be equals to 2, I will have what? A subscript 2 x raised to the power what? 2. So that is how we arrive at this one. As I've said, we make use of this equation at the ending part. So if I have n raised to the power of, if I take n to be equals to 3, so I will have a subscript 3 x raised to the power of what? X raised to the power of 3. X raised to the power of 3. So that is how we arrive at this part. And the same thing applicable to what? To others. To infinity. Like that. Okay. Before we proceed, I would like us to look at this problem. I mean, this equation given to us. You see that from this equation, we have what? Y. We have what? Y prime. And we have what? Y prime prime. And if you look at this general solution is for y. That is, I said it earlier that I can also rewrite it as y equals to this. So this simply tells us that it's just a function of x. That is the meaning of this. So this is the equation for y. If the equation for y is this, I will need to substitute, that is, I will replace y here with the equation for y, which is this. I will replace it with this equation here. Then what about y prime? Are we not replacing for y prime? Yes, we need to replace it. We need to replace y prime as well. And what about y prime prime? We also need to replace this y prime prime. So we need to, before we can do that, we need to get the equation for y prime and as well the equation for y prime prime. And we can derive the equation for y prime from where? From the equation of y here. We can also derive the equation for y prime prime from the equation of what? From the equation of what? Y as well. Okay? We need to write the equation back. Just as I've said that we have y prime, we have y prime prime, and we have y itself. So this y is this. So this y prime is this, and then this y prime prime is this. So we have only know the equation. We only know the equation for y, but we don't know the equation for y prime, and we don't know the equation for y prime prime. So we need to derive the equation for y prime and then the equation for y prime prime. Okay, so how do you derive the equation for y prime and y prime prime? We need to understand what y prime stand for, and we need to understand what y prime prime stand for. Y prime is the same thing as what? The y dx. I said earlier that y here is a function of what? It's a function of this x. So to get y prime, I will need to differentiate this y with its function, which is x. So I'm differentiating y with respect to x. That is the y dx. Okay. So and the y dx, as I've said, that is the same thing as what? Y prime. What about y prime prime? What does y prime prime mean? If I differentiate this y once, if I differentiate it once for the first time, I will have y prime. So if I now differentiate this for the second time, I will have what? Y prime prime. So we can see here that y prime prime is the second derivative, while y prime is the first derivative. Okay, so we need to know how we can differentiate this y with respect to x for the first time to get our y prime, and we also need to, whatever we have then, we need to differentiate it for the second time to get our what? Our y prime prime. So this is the equation for y. Yes, as I've said that we need to differentiate it to get our y prime and y prime prime. So if this is the equation for y, how are we going to get this y prime? It's just the general method of differentiation we apply here. I hope you are familiar with general method of differentiation. If you are not familiar, you can watch my video, although I will also explain it here. Don't be confused about this part. I've explained it earlier that it's just a function. So if I'm differentiating this y now with respect to the function here, which is x, I will make use of general method. I will use the power of this x to multiply it here. Then after I multiply it, I will then subtract what? 1 from the power. That is just the general method of differentiation. That is just it. It's very simple. So if I should do that, I will have my y prime, and my y prime will be what? Will be this. Don't forget that I said we'll use the power, which is n, the power of the x to multiply, which is n. I used to multiply it, and just as you can see here, you can see it here, and then I will subtract 1 from the power, which is n, that is n minus 1. So that is how we arrive at n minus 1 here. Okay. Now we have gotten y prime, that is the first derivative. Mind you that whenever you differentiate, here will no longer be 0. If I differentiate for the first time, it will be what? It will change to 1. When I differentiate it for the first time, it changed to x, n equals to what? This one changed to n equals to 1. If I differentiate it for the first time. So if I now differentiate it for the second time, it will now change to n equals to what? N equals to 2. So how am I going to differentiate this for the second time? It's still the same approach. I will use the power here, but mind you that the power here is no longer n, but the power here is what? It has become n minus what? N minus 1. So this time I will use n minus 1 to multiply what is here before. I will use to multiply it. But don't forget that n is already existing here now. So I will just multiply it with what? N minus 1. Then I will then subtract what? Minus 1 again from it. So that is how differentiation, general method of differentiation works. I will use it to multiply it. I will use this power, n minus 1, to multiply it again. Then I will subtract what? Minus, I will subtract 1 from it. So I will arrive at our what? That will be the second derivative, and that is our y prime prime. So this gives us what, this is what we have if we differentiate it. Yes, let me show you something. I need to show you something here. You know, we already have n here before. So this is the n. Okay. So I now said that you will use the power here to do what? The power here, which is n minus 1. You use to do what? You use to multiply it here. So that is how we arrive at what? N minus 1 here. So the remaining parts are now here. But don't forget that I said whenever you differentiate, you subtract 1. So if you subtract 1, you know, we have minus 1 here before. So this, it becomes what? N. It becomes n minus 1 minus what? Minus 1. So which become minus 1 will give us what? Minus 2. So it becomes n minus 2. So the power here becomes what? N what? N minus 2. So that is, now we can say that we have gotten the equation for y prime, which is this, and then we have gotten the equation for y prime prime, which is this. So we need to substitute them. Although we're already familiar with equation for y before, which is this. Equation for y prime, which is now this. Then equation for y prime prime is now this. So from this problem given, I will replace this y prime prime with the equation for y prime prime. And the equation for y prime prime is this. So I will replace this y prime here with the equation of what? Y prime. And the equation for y prime is this. So I will replace this y here with the equation for y. And the equation for y is what? Is this. Okay? So having done that, we need to write the equation back, I mean the problem back, which then become this. Yeah, just as you can see here, because I have explained that we need to substitute the equation for y to replace y, and then we need to substitute, you know, this x minus this 1 minus x squared is this, and then y prime prime here, this equation we have replaced it with the equation here. Okay, and then mind you, this minus must be there. This is a minus here. So 2x, this is 2x. So the equation, we have replaced y prime with the equation for y prime. Okay, and the equation for y prime is this. Okay, and then we have plus 6 here. So this is the plus 6 here. So we replace the equation, we replace y with the equation of y, and the equation for y is this. Okay, so having done that, we proceed to the next by expanding. What does this mean? We need to expand this equation by using this one to multiply this. Then I will use this x squared to multiply it again. Then come back here. I will use this minus 2x. I will use this 2x to multiply this. Then I will also use what? This 6 to multiply this. Okay, so this is what we have. So to do that, to expand, we need to write the equation back. So this is the equation before us. Yeah, to expand this, I'll be taking them one after the other. I will expand from here to here. That is, I will expand this. Then I will come back to the next one. I will expand this. Then I will then come back to the last one. I will expand this. So I'll be considering them one after the other. So what is expansion? It's just like me opening this bracket here. So why this part? I will just use this one to multiply it here. Then I will use 6 to multiply it here. So if I'm to expand this, I will use this one to multiply this. That is, I will use this one here to multiply this, and then I will use this s squared to multiply it as well. Okay, so I'll be considering this one after the other. I will consider this part separate. I will consider this part first, followed by this part, then followed by this part. All right, we have so yeah, for the first part, which is this part from here to here, so I'll figure out the part here to be this. Of course, I know that you are not confused that y prime prime, I've replaced it with the equation here. That is the equation for y prime prime that we proved earlier. Okay, so to do that, I've said that we use this one to multiply it. Then you take this minus before you multiply the second one. Then we have s squared to multiply it. So and then we have what? We have this. So this is where I use 1 to multiply it now. As you can see, I use 1 to multiply it. But I'm not having any issue with this because I know that anything I multiply 1 with will definitely give me that thing. Because if I multiply 1 with, let's say I multiply 1 with x raised to the power of 5, I will have what? X raised to the power of 5. Anything I multiply 1 with will just give me that particular thing. So I know that if I multiply 1 with this, I will still have what? This. Okay? So I'm having issue here by multiplying. My concern is to multiply this x squared with this, and just as you can see it here, okay. But don't forget, take notes. You have to write all these things down, and if you have any questions, you can drop it on the comments. Don't forget that I said earlier that I'm still dealing with this part just from here to here only. So which I figure out to be this. I'm still expanding that part only. So I will still come back to this. Take note of that. Don't forget. All right. So by expanding this, we have what? Yeah, I will need to. Yeah, we have something like this. What does this mean? Now, I said earlier that I don't have any issue with this by multiplying this, but here now I'll just bring this x to where there's x here to make the multiplication more convenient. I will multiply it with where there's x here. That is, I will multiply it with this, and so I now bring out this part here. I brought out this part to be this. So I've already brought the x. I took the x from this part to this part to multiply this to make the multiplication more convenient. What you're actually doing, that is to make it more convenient. So just as you can see it here, okay. So by multiplying this and this together, if you remember from me, this is that you can see that we have x here and then we have x here. So what will I do? I will pick one x. That is, you can see that this part, I've already figured it out to be this part. So from indices, I'll pick one x to represent both, which is this. So what will happen to the power? You know, the first x has a power of what? N minus 2. While the second x has a power of what? 2. So what will happen between this power is being determined by what? By this multiplication here. We said in this is that multiplication chain to what? Multiplication chain to addition. So I will add the two power together. The first power here is n minus 2 and the second power is 2. So this multiplication chain to addition in between the two of them, just as you can see it here. So if I'm to simplify this, you know, minus 2 plus 2 will cancel out. Minus 2 plus 2 will give me 0. So I will be left with what? N. So here will give me x to the power of n. That is, everything here for this part we give me what? X raised to the power of what? N. So I will replace it with x raised to the power of n. Mind you that this part from here to here is just from this to this part. Okay, so I will replace this part now. I've used this x to multiply it. I've used this x to multiply it. So I will replace it. X will no longer be here again. So I'll just replace this part with what? X raised to the power of what? I'll just replace it with x raised to the power of n. So if I replace it with x raised to the power of n, that is, I will still have from here to here, minus what I arrived at here. That is what I got from the solution of this. I mean, from the breakdown of this. So that is, I will combine it with what I got here from the breakdown of this. Then, but remember, I keep saying this, that I'm still dealing with from here to here. So, okay, yeah. So I've already done for the first part now. If you remember that when I said that if I use this one to multiply it, it will still give me from here to here if I multiply it with 1, and that is from here to here. And then when I use x squared to multiply it, you remember that this is what we arrived at, that is this. So let's go to the second part. So I've done with I've done with 1 minus x raised to the power of 2y prime prime. So the next one is to consider the second part, which is 2xy prime. That is, you know that 2xy prime is given to be this from the equation. Of course, you know that this 2x here is this y prime is given to be this equation for y prime we got earlier. So we need to, what will I do? I'll just use this 2 to multiply it here, bring the 2 here, then I will bring x to where there's x here. I will multiply with this x here. So just as we have done for the first one. So we have yeah, you can see it here that I've used the 2 here to multiply it here. So you can see the 2 here now. You can see it here. Then I've already took the x. That is, I took the x here to multiply it here. So just as you can see it here. Just as you can see here. So I hope you are still familiar with indices. You can see that the law of indices still applies here. That is, I pick one x to represent both. Then I add the power. The original power for this is n minus 1. And we can see it here to be n minus 1. This multiplication change to plus. We can see the plus here. Then plus this other power, which is 1. Just as you can see here. So what will this give us? Yeah, it will give us something like this. Because yeah, minus 1 plus 1 will cancel out. At least it will give me 0. This will give me 0. I will be left with what? X raised to the power of n. So that is I'll be left with x raised to the power of n here. So this is the second part. Now we have this. This was the first part. This is the second part. And then we need to consider the third part, which is the last part. Consider the third part. Yeah, this third part is 6y. So I hope you have, yeah, this 6, this is it here. The equation for y, this is it here. So this part is very simple. Since it is only 6, I'll just take the 6 here to multiply it here. That's just it. So just as you can see here, very, very simple. Yeah. Since we have gotten that, we need to write out we can see it there. The first part is this. Which is this. And then the second part, which is this. Then to the third part, which is this. So we then combine them. So instead of me to write this part now, we have simplified this part. That is this part. We have gotten this. So I will replace this from here to here with this. Okay. Then I will replace from here to here with what? With this. Then I will replace from here to here with what? With this. So we have what? Yeah, these are equations. So this is what we arrive at. Yeah, this is what we arrived at. Okay. Yeah, this is what we arrived. This is our next this thing. But if you look at this, we are still having an issue to tackle here. We need to break down something. Now, if you look at that x, I want you to consider the power of x here at this point. Considering the power of x, you see that this x here has the power of what? It has the power of n minus 2. This x here has the power of what? N. This x here has the power of what? N. This x here has the power of what? N. Now you can see that this 3 power, this. Now you can see that these 3, they have the same power, but it is only this that is different. Only this that is different. So we need to do something to this to make the power of x. Take note, we are dealing with the power of x. To make the power of x the same thing as what? As this, as the first one here, as this and this. So what are we going to do to that? To make it the same. To make it the same, we have to leave. So we say that what? Next is to make the power of x the same or true. Okay, by saying what? Let n equals to what? Let n equals to n plus 2. That is, if we replace n with n plus 2, what will happen? That is, if I replace n with n plus 2, if this n here becomes n plus 2, mind you that this minus 2 is still there. So, we are only dealing with this part. We are dealing with this part. And you know that this part now, we know that this part is still the same thing as from here to here, right? So we are only dealing with just from here to here alone. Just only this side. So whenever we are replacing n with n plus 2, we only this with this side alone. Only this aspect alone. That is, anywhere you come across n in this entire place here, you will replace it with n plus 2. Anywhere there's n, you must replace all of them with n plus 2. Because we are trying to make this part to be equal with what? We are trying to make it equal with this part. You understand? So we only replace anywhere there's n here with n plus 2. Alright, then if I replace that part with n plus 2, so what will I have? This will become n plus 2 minus this 2 that is there before. So of course you know that plus 2 minus 2, the 2 will cancel out. I'll be left with what? S to the power of n, which will now be exactly the same thing as what? Which will be exactly the same thing as others. Okay? So, yeah, you can see it here that I've replaced my n with what? N plus 2. I replace this n here, just only this n with n plus 2, and you can see it here. Mind you that this equal to 2 still remain the same. I replace this n here with n plus 2. Anywhere there's n, as far as we are dealing with only this part, anywhere there's n, you must replace them with n plus 2. So I replace this n here with n plus 2. You can see it here. So I replace this n here. Mind you that this n here has minus 1 before. So I replace this n here with n plus 2. So you can see it here. Minus the this one that is there before. So minus 1. Now you see there's n here again. It's subscript n. So I will replace it with n plus 2, just as you can see it here. You can see it here. So I replace this n2, this n that is here, with n plus 2. So you can see it here, n plus 2. Okay, so but you see that I didn't touch others. Others remain the same. I didn't touch others because we are trying to make this part, the power of x here from this part, to be the same with others. Yeah, what will I have? You know, after I replace the n with n plus 2, you know, I told you that plus 2 minus 2 will cancel out. Then you notice that here before we have it to be, I replace this n here with n plus 2, and we have 2 here before, right? So if I bring that 2 that is here, you know, to the other side, it becomes 2 minus 2, and 2 minus 2 will give me 0. So that's why I write 0 here. And then n plus 2 still remain the same here. You know, here we have n plus 2 minus 1 here. Okay, we have this place to be n plus 2 minus 1. So plus 2 minus 1 will give me plus 1. So that is how we are left with n plus 1 here. So here still remain n plus 2, and then here we have it to be n. Okay. So what is the next thing now? Now we have done with the power of x. We have done with the power of x. Okay. Now we want to consider the down part. That is the first one we consider was the upper part. The upper part, by saying that by making the number, by making the power of x to be the same, by making the power of x to be the same, which is the upper part, by making the power of x to be the same. So next thing is to make this n here to be the same. You know, here is n equals to 0, but here we have it to be n equals to 2. Are they the same? No. We have this place to be n equals to 1, and we have this place to be n equals to 0. So we need to make n the same or true. We need to make sure that our n are equal to 2 or true. So what are we going to do to do that? What are we going to do? Now to do that, I will, you know, this n begin from 0 to where? If you check it, it begins from 0 to infinity. That is, it's moving from 0 to 1 to 2 to 3 to 4 to 5 to 6, like that to infinity. But I'm not going towards infinity side. I will only stop at 2 because I want it to be equal to this 2 here. Because you can say that 2 is the maximum here. 2 is the maximum here. So I want it to be equal to this 2. Even this one, we have to move from this 1 to 2 to be equal to this 2. That is our n. Then this one, we also move from 0 to 2 to make everything to be equal to 2. What will I have? And how am I going to do this thing? I will do that by saying, now from this equation, I will first of all take my n to be equal to 0. Don't forget that I said I will take my, I will be moving from 0 to 2. I will stop at 2. So if I substitute n with 0, so that is anywhere there's n here, you know, I'm dealing with this part first. Take note, I want to consider this part first. Then, you know, I'm not considering anything here. This is already n equals to 2 here. You can see I'm not considering anything from here to here. Then after done that, I will then consider this part by make sure that our n equals to 2 here. Then I will consider the last one by make sure that our n equals to 2 here. But I don't have anything to do with this because this one is already having n equals to 2. It's the highest. So I want to make sure that this n move from 0 to 2 first. Then how am I going to do that? I will replace anywhere there's n. I will first of all replace it with 0. I will place it with 0. I will place this with 0. Then I will place this with 0. So that is what I did here. You can see it here. So you can see when I replace this, this n here with 0, you can see it here that we have 0. So plus 2, this plus 2 still remain plus 2 here. Then when I replace this n with 0, you can see it here. Sorry, you can see it here. Yeah, you can see it here. Then this plus 1 still remain plus 1 here. So I replace this n here to be equals to 0. You can see it here. Then I replace this n here, which is this power here, to be equals to 0. Okay, now we can see that 0 plus 2 here will give me 2, and 0 plus 1 will give me what? 1. Okay, so 2 times 1 will give me what? 2. So that is how we arrive at 2 here. That is how we arrive at 2 there. Then 0 plus 2 here, what will it give me? It will give me 2. So I will have what? A subscript 2. You can see A subscript 2 here. But x raised to power 0 will give me what? 1. Of course, you know that any number or any variable raised to power 0 will give me what? 1. So I don't need to write 1 here. So this is what we arrive at the first part by substituting n equals to 0. So the next one is to substitute n to be equals to 1. You know, I told you that we stop at 2. So when I substitute n to be equals to 1, I have what? So now, from this same equation, you know, I've copied this same equation, copied it from here. Still the same thing as this. The first part, this answer was when I substituted n equals to 0. Why this second part now is when I substituted n to be equals to 1. And how do we go about that? So at this part now, you know, n has moved from 0 to 1 now. So I replace this n here with 1, just as you can see here. Then these two still remain the same here. Okay. Then I replace this n here as well to be equals to 1. You can see it here. Then this plus 1 still remain here. Okay. So I replace this n here with 1, just as you can see here. Then I replace this n here with 1, just as you can see here. So yeah, having done that, we have n plus 1 plus 2 will give me 3. So you can see the 3 here. Then I have 1 plus 1 will give me 2. So you can see the 2 here. So a subscript 1 plus 2 will give me a subscript 1 plus 2 will give me a subscript 3. Sorry, it's a mistake. Here is a subscript 3. So you can see it here. You can see it here. So it's a subscript 3. So and then yeah, 3 times 2 will give me 6. You can see the 6 here. Then a subscript 2, this one will be a subscript 3, as I've explained, because a subscript 1 plus 2 will give me 3. So you can see that we have a subscript 3 here. Then I have x raised to power what? X raised to power what? 1. Now, if you look at this very well, you see that I substituted, I moved from 0 to 1 here. Then when I get to 2, do you know what will happen? I will only write it as this. This n will only change to be equals to 2 here, but I will not substitute it. Why? Because if I substitute it, I will have an answer that will look like this. But I'm not looking for an answer that will look like this. I'm looking for an equation whereby an n will remain equals to 2, which will match with this one here, because we are trying to get an equation like this. We're trying to get an equation like this. So what will I do? You know, this, what I got here, this and then this are still part of this. You know, it are still part of the series of this. So I will add this plus this plus, when I now substituted n equals to 2, just as you can see here, this is the equation. You know, this is the equation we are dealing with. So when I took n to be equals to 2, now I said that when I get to 2, I will not substitute it, because I want this to match with this. It's what we have here. It's what we have here from the general equation. So I will not substitute it. So what will I do is that I will add the first one, what I got, the value I got when n equals to 1 is 0. Sorry, I will have the first one when what I got when n equals to 0, plus the first one when n equals to 1. Then I will then add it with when n equals to what? 2 here. So I will then replace it with this. Don't forget that I said this is already n equals to 2. I don't need to do anything with that. Then the next one I will then come back to this, come back to this. So this is, you can see that it's very, very simple. If you have any question, you can drop it on the comments, and then, as I said, don't forget to like and share with your friends. So I will replace this one now. I will need to replace it with the series, with the series I got. Now I've moved the value of this n here from 0 to 2 now. Okay, so we have this. Yeah, I explained earlier that I moved from 0 to 2. So when I substituted n equals to 0 earlier for the first time, this is what I got. When I now substitute n equals to 2, n equals to 1, this is what I got. Then when I'm substituting, I will just take n equals to 2. 2 is the next one. We are already familiar with that. So I will just write it as 2. I can substitute 2 inside, but I'm not substituting it because I want this 2 here to match with this. And you know that this is this, which is the one we are trying to make others look like. So that is why I'm not substituting this 2 there. So you can see that you can see here that I've done for this part, which has given me from here to here, is what I got from here to from here to this part. Then this part, I just join this part along immediately, which is from this part, because this part is automatically n equals to 2. So the next one I will look at is from this part to this part, then followed by from this part to this part. See, once you can understand this, please get it clear. Others, they are very, very simple. You can easily get it. So we need to consider the next part, that is from this part to this part. Okay. So we are now considering the second part now, which is, we are considering the next part, that is we are now considering this part now. This part, yes. So you can see it here now. So just as you can see here. So any here is equals to 1. So I will just move from 1 to 2. I will just move from 1 to 2. Don't forget that I said whenever we get to 2, we just stopped. So when n equals to 1, when n equals to 1, this is what I will have. That is, I will just substitute where there's n to be 1, 1, and 1. So here will become 2 times 1, just as you can see here. And this subscript of a here will change to 1, just as you can see here. That is here. Then this power here will change to 1. That is x to the power of a will just change to what? 1 here. Yeah. So 2 times 1 will give me what? 2 times 1 will give me 2. A subscript 1 still remain the same. And then x to the power of 1 will still give me x. X is the same thing as what? X to the power of 1. So I've substituted n to be equals to what? 1. What is the next thing I'm going to do now? I've moved from 1. I said I'm moving from 1 to 2. After 1, what follows is 2. So I will then say, let n equals to what? 2. But whenever I get to 2, I will stop. I will not substitute, because I want it to be in equation form. Okay? I think this is getting more interesting. So when n equals to 2 now, I will stop. Yeah, when n equals to 2, I will stop. So you can see from this that this was the answer I got. This was the answer I got when n equals to 1. And here is it, yeah? But when n equals to 2, I will only write it as n equals to 2, but I will not substitute 2 into this. So just as you can see here, I just wrote it as n equals to 2. That is, I have arrived at n equals to 2, but I'm not substituting it because I want the equation to look like others that we have that we have got since. Okay, so we need to, then you can see that I'm done with this part now. This part now, from here to here, this is what it gave me. From here to here, this is what I have. That is, let me make this thing more clearer. Yeah, this is what I arrived at. That is, from this part is given to be this part, is given to be this part, from this part. Yeah, so that is it there. Okay, so the last one I'll be looking at is this part from here to here. So that is the last thing I'll be looking at. So I've already brought out the third part here, as you can see it here. So I'm moving this part, I'm moving from my n equals to 0 to what? To n equals to 2. We always stop at 2. I think as you are solving this thing, you know, it's getting more familiar. Don't forget to subscribe to Tutor Ayodele, like, comment, and share with your friends. Okay, so when n equals to 0, I will replace anywhere there's n to be 0, this to be 0. Yes, this is what I will have, because if I replace this with 0, I will have a naught. You can see that we have a subscript 0, and then I will have x raised to the power what? You know, this x raised to the power of n. So if I replace it, I will have it to be x raised to the power of 0. Then you know that so I will have it like this. So 6, this 6, here is it here. A subscript 0, here is it here. So x raised to the power of 0, you know, it will give me 1. To give us 1. So I don't need to write 1. Yeah, I don't need to write it here. So this is what we arrive at when x equals to, sorry, when n equals to 0. So the next one is to say when n equals to 1. So because we are stopping at 2, so next one after 0 is 1. So when n equals to 1, wow, this is what we arrive at. When n equals to 1, we have it like this. You can see that I will place anywhere there's n here with 1. I will replace it with 1, and then I will replace this 2 with 1. So this, you can see it here. Wow. So we have we have 6a subscript 1, just as you can see here, 6a subscript 1, x raised to the power of 1. And you know that x raised to the power of 1 is the same thing as what? Is the same thing as x. So take note of this too, that when n equals to 0, this is what I arrive at the answer. When n equals to 1, this is what we arrived at the answer. Okay, so the next one after 1 is what? Is to say, no, the next one after n equals to 1 is to say n equals to 2. But I think this is getting more interesting now, that whenever you get to n equals to 2, we will not substitute 2 into the equation, but we just leave it that, okay, we have gotten to 2, but we just leave it. We just leave it like that. So this and this, they are in the same series with the other. So we add them together plus when n equals to 2. So all of them are still in the same series. In the same series. So when n equals to 2, this is what we arrive at. Because when n equals to 1, it's just like I'm moving from, you know, I said that this is like any moving from 0 to infinity. Of course, we can't get to infinity. So when n equals to 0, this is what I arrive at. When n equals to 1, this is what I arrive at. When n equals to 2, this is it. I can substitute these two direct, but I'm not dealing with that because I want it to be in equation form. So this is what we are now arrived at. Okay. So now we are to join all of them together. If we are to join all of them together, we have something like this. This becomes something like this. So I need to show you something quickly here. Here's supposed to be minus. Here is minus. Here is minus, not plus. It's minus. Because if you remember that when I substituted n to be equals to 1 here, this is what I got, right? So when n equals to 2, this is it here. I didn't substitute them 2 inside. I just leave it like that. So both this and this are the series form of what? This. Okay, so you can see that there's minus here at the front here. So the minus will affect, the minus will be for both of them. This, it will affect both this and this. Okay, so what is here is minus. Take note of that. It's minus, not plus. Okay, so we move on. So let me just show you something briefly here. If you remember that when I said that we move from 0 to 2, B is already in 2, balance. Then we move from 1 to 2 here, and we move from 0 to 2 here. So I move from 0 to 2. That is the first time I substitute the 0 to this. This is what I got. The second time when I substitute, the next one after 0 is 1. I substituted 1 into it. This is what I got. Then when I get to n equals to 2, I stopped. I didn't substitute, but I wrote the equation out, which is this. So you see that you see from here, sorry, it's from here, like yeah, you see that both the three of them from here to here are still in the same series, because they are still the series of this. They are still in the same series. They belong to the series of this. Okay, so this part now from here to here, this part from here to here is given to be this. This part from here to here, from here to here, just as you can see here. Wow. So, and then this part from here to here, I move from n equals to 1 to n equals to 2. So when n equals to 1 for the first time, this is what we arrived at. So, but when n equals to 2, we just stop there. We leave it as equation. We left it as equation, right? So this is it, just as you can see here. Sorry, just as you can see here. Yes, just as you can see here. So that is the series of this from this part to this part is given from here to here to here. Okay, so the last one here is this part, and just as you can see it here, just as you can see it there, that here I move from 0 to 2. So when n equals to 0, I just replace where there's n to be 0, where there's n to be 0. So this is what we arrive at. You can remember this thing, our previous work here. So when n equals to 1, this is what we arrive at. And then when n equals to 2, I stopped at 2. I wrote the equation out, which is this. So I just stopped there. Wow. So we are getting towards the ending part of this aspect. So next thing is to collect the coefficient of x raised to power 0, x raised to power 1, and x raised to power of n, and equate them to be equal to 0. First thing, I will need to tell you what x raised to power 0 mean. So I will need to tell you what x raised to power 0 mean. Yeah, we arrive at this. Okay, yeah, I said I will explain what x raised to power 0 mean. X raised to power 0 means x will not be there at all. Why? Because if I put x raised to power 0 here, it will still the same thing as 1, and 1 times this will still give me this. So I can say that the value of the x here will be, here we are, here is the same thing as x raised to power 0, because x will not be there. It will give us 1. So if I use 1 to multiply, it will still give me that particular 2a subscript 2. So you now look at anyone that does not have x. So anyone that does not have x at all, like this part, you can see that this one too does not have any x. So we can say that x here is raised to power of 0, because it will give me 1, and if I use the 1 to multiply, it will still give me. So that is just it. So you can see that others, you can see this one has x raised to power 1, this one has x raised to power 1, why this one has x raised to power 1, why this one has x raised to power of n. We said that we are equating, that is collecting the coefficient of x raised to power 0, that is those one that does not have any x raised to power 1, just as you can see it here, and then x raised to power of n, just as you can see it here. Which other one? You can see it here, you can see it here, and then you can see it here as well. So that is for x raised to power of n. We will equate them to be equal to 0. So considering the first one, x raised to power 0, those one that does not have x, we bring them out. This and this is just the only two that does not have x, so we bring them out, and you can see it here. We equate them to be equals to 0. We equate them to be equals to 0. So when I equate them to be equals to 0, you know, a subscript 2 here is the biggest here. So I'll make a subscript 2 to be the subject of the formula. So I will take this plus a subscript 0 to the other side. It become what? It become minus. So I will take this plus 6. Yeah, it will become minus. It will become minus 6 a subscript 0. So I will divide both side by 2 to get a subscript 2. So I will have it as this. So this is what we arrive at the answer. This is for a subscript 2. Therefore, write all these parameters down. Write this down. The value of a2 is given to be this. We still make use of it. So that is the value for a subscript 2. So yeah, for x raised to the power of 1, that is those parts that has what? Those parts that has x to be in power of 1. Like this part, as I've said earlier, this part, this aspect, and this aspect. So what is the coefficient of x raised to the power of 1? So what is the coefficient of x raised to the power of 1 here? What is the coefficient of x raised to the power of 1 here? Is what? Is 63a. That is 6. Is what? Is 6a subscript 3. While the coefficient of x raised to the power of 1 here is what? Minus 2a subscript 1. And the coefficient of, what is the coefficient? That is, coefficient means beside. So what is beside it? We have it to be what? 6a subscript 1. So I bring the three of them out here, just as you can see here. I equate them to be what? To be equal to what? To be equal to 0. To be equal to 0 here. So you can see that a subscript 3 is the biggest. So I will make it subject to the formula. And to do that, we need to simplify this. This is a subscript 1, a subscript, we have a subscript 1 here. So I can simplify this and this first. So minus 2a subscript 1 plus 6a subscript 1. Of course, you know that minus 2 plus 6 will give me plus 4. So I will have it to be plus 4a subscript 1. So I will take this plus 4a subscript 1 to the other side to make a subscript 3 subject to the formula. So I will have it to be this. Just as you can see here, I will have it to be this. So write these parameters down. We said earlier that our a subscript 2 give us this, while our a subscript 3 give us this. So write all those parameters down. Okay. So we look at the third one, which is our x raised to the coefficient of x raised to the power of 1. But take note of something. Let me show you something here. Now, this is our x raised to the power of 1. This is our x raised to the power of n. This x raised to the power of n. So what is the coefficient? The coefficient is this, from here to here. Then we have from here for x raised to the power of n. This is another x, from here to here is the coefficient of this x raised to the power of n here. Okay, so I need to identify them out. This is another x raised to the power of n. So what is the coefficient? We have it to be this. And then the third one, the last one, we have, we have x raised to the power of n here. So what is the coefficient? We have it to be this. So I'll bring this, and this together. So we have it to be this. So we have it to be this. So this is our equation. So for x raised to the power of n, yes, just as you can see here, that the first one here, this is the coefficient of, we have x raised to the power of n here. So the coefficient here is what? X plus 2 brackets, x plus 1 bracket. And we have another x raised to the power of n here. So what is beside x raised to the power of n? We have it to be what? N into bracket n minus 1. You can see it here. So you can see that, this a subscript n plus 2 is still part of the coefficient. So you can see it here. You can see it here for the first one. And then for the second one, from here to here, you can see it here too. So you can see there. Then the third one, which is this, from here to here, is the coefficient of this. Is the coefficient of this x raised to the power of n. So just as you can see it here, I'm not writing x raised to the power of n. I'm not writing there because I'm considering its coefficient. So what's the last one? We have x raised to the power of n here as well. So I'll bring its coefficient out here, which is 6a subscript n. So you can see it here now. So we can say that from here we can see that a subscript n plus 2 we can say is the biggest. Okay, so we need to make this a subscript n subject to the formula, and to do that we need to move from this part to this part to the other side here. We need to move them to the other side here, and to do that we have it to be, that our value of our n must be greater than or equal to 2. If you remember that we stopped at 2, so that is at least the value of our n at which we stopped is what? Is 2. So we can move from 2 higher. So making this a subscript n subject to the formula, as I've explained, as I've told you earlier, that we make this a subscript n subject to the formula. So others like this from here to here we cross to the other side. So we have it to be this. You can see that when this part, this part from here to here, when it moves to the other side, this minus here will change to plus. So you can see that there's no longer minus there. So when this part minus 2n a subscript n move to the other side, it will change to plus. You can see here that it changed to plus, the minus. So when this part plus 6a subscript n move to the other side, it changed to what? Minus 6a subscript n. So I hope we are familiar with that. So the next thing is just to divide both sides by the coefficient of this. The coefficient of this is this. So we just divide both sides by that, then we get our value for that. So we have it to be this. So when we have already divided the coefficient of a subscript n plus 2, you can see this is what we have now. This divided, you can see this division sign here. Divided by this. Okay, so that is for that. Then, so what is the next thing? So you can see it here. So we know that our value of our n is greater than or equals to 2. Okay, so when we said our value of n is greater than or equals to 2, that is, we can start from 2. We stopped at 2 earlier when we began to substitute our n equals to 0, n equals to 1, n equals to 2. We stopped at 2, if you can remember. So now we are now continuing from 2 now from here. So when n equals to 2, if I should bring 2 into this equation here, now if I replace anywhere there's n here to be 2, so this is what we have. Here. Okay, so you see that I will have this n here will be replaced with 2, this n here will be replaced with 2, n here will be replaced with 2, just as you can see here. So we have it to be this. Then, so if I say 2 minus 1 will give me 1. So 1 times 2 will give me 2 plus, now here I have it to be, I've already have plus 2 here now. Here I have it to be plus 2. I have it to be plus 2. But here now I have 2 times 2 will give me 4 minus 6. It will give me what? It will give me 4 minus 6 will give me minus 2, right? So, and don't forget that I have plus 2 here. From here I have it to be plus 2. So plus 2 minus 2 will give me what? Will give me 0. So 0 divided by everything here will definitely give me what? 0 divided by everything here will give me 0. So that is how we arrive at 0. So But mind you that if you say n equals to 2 here, so here you must replace this one to be 2. So we have our a4, that is 2 plus 2 here will give me 4. So a subscript 4, sorry, we have it to be a subscript 4 to be equals to what? To be equals to 0. Then we said that n is greater than or equal to 2. So that is, we can begin from 2 upward. So after 2, what do you think next is what? To say that when n equals to 3. So when n equals to 3, if I should substitute 3 into the same equation from here, here will become 3 plus 2 here. It become 3 plus 2. Then I will then substitute anywhere there's n here to be equals to 3. So this is what we arrived as this. You can see it here. So therefore, here it becomes what? 5. That is a subscript 5 here. So this is what we arrive as the answer. Okay? This is what we arrived as the answer. So we recall. You see the reason why I said you should write all these things down. We recalled earlier that our a subscript 3 is given to be minus 2 over 3 a subscript 1. If you remember, you can check it. Okay? So therefore, our a subscript 5, if you remember that from our a subscript 5, we have our a subscript 5 to be this 3 over 10 a subscript 3. And so, this our a subscript 5 is 3 over 10 a subscript 3. So we now recall that our a subscript 3 was given to be this. Now if you check, so we are now replacing the a subscript 3 that's supposed to be here with this. So this is what we arrived as our a subscript 5 value. So what are we trying to do in essence is that, well, okay, when I show you the last series, you will understand what this thing actually means, why we did. So when n equals to 4, from the same equation, when n equals to 4, this is what we have. Of course, this is what we have. From the same equation, this is what we have. So that is for when n equals to 4. That is to infinity. We can't start saying n equals to 5, n equals to 6, n equals to 7, like that. When n equals to 6 too, it will give us 0. That is, if we replace the same equation, if you replace the value of n to be equals to 6, we arrive at 0. Then recall from the equation I derived earlier at the beginning of this class. Given the solution of y, if you recall this equation, yes. So what happened here is that, we have from this equation, we have a subscript 0, a subscript 1, a subscript 2, a subscript 3, a subscript 4, a subscript 5, a subscript 6. We stop at 6 for now. So, this a subscript 6 is given to be 0. So if I use 0 to multiply this, it will give me 0. So automatically this will cancel out. But we want everything to be in form of a subscript 0 and a subscript 1 alone. So that is why we kept substituting those parameters. I mean those values we have gotten. Like for example, when we got a subscript 5, a subscript 5 to be 3 over 10 a subscript 3. So we replace that a subscript 3 to ensure that we have a subscript 1 there. So we are trying to make them equal. So we then substitute the value of our a subscript 2. We replace the value of our a subscript 3 with what we have, the value of our a subscript 4 with what we have, and then the value of our a subscript 5 with what we had earlier. So by substituting, we have this. Yes, this is what we have. If you remember that our a2, this is the value for our a2. Now this is what we got for our a2, and then this is what we got to be our a3. This is our a3. Our a3 was given to be minus 2 over 3 a1, and our a2 was given to be minus 3 a0. Okay, so that is a subscript 0. So we don't have a4 because a4 the value we got for A4 was 0, and then we don't have A6 as well. It was 0. So this was our A5. This was the value we got for our A5, minus 1 over 5 A1. So then from this we try to put this into 2. Those that has A0, this and this, bring them together. Of course, you know that if you bring these two together, then what is common between these two is that we have A0 here. If I bring A0 out here to be the subject of the formula, what am I left with? What am I left with here? I'll be left with 1. So I'll be left with what? 1. Okay? Minus these 3. You know, if I bring A0 out here as well, I'll be left with minus 3x raised to the power of 3. So I'll be left with minus 3x raised to the power of 3. Yeah, you can see it here to infinity like that. And those that has A1, bring them together like this, and this as well. So we join them together. Yes, we join them together. This one, this, and this. So from this, you see that if I bring out A1, which is common among them, this is given to be the A1. Okay, so what am I left with? I'll be left with what? I'll be left with x here. So you can see it here. You can see it. So from here, if I bring out A1, which is already out here already, it's already out here. So I'll be left with minus 2 over 3 x raised to the power of 3. So you can see it here, minus 2 over 3 x raised to the power of 3. So if I bring out A1 here, if I bring it out just as you have seen it here, you can see it here. So I'll be left with minus 1 over 5 x raised to the power of 5. So just as you can see here, minus 1 over 5 x raised to the power of 5 plus to infinity like that. So this is what we arrived as our final answer. So we compare with this. So we compare with this. If we like, this and this from here to here is just like from here to here. Why this is from here to here? You can see that this is our A0 out here. This is our A0. And you can see our A0 here. So why this is given to be this? Okay, and you can see our A1 here. So you can see it here. A1 here. You can see it out here. A1, and then y2 as a function of x is given from this to this. You can see now. So that is it. Stay tuned for more tutorial video. Please like the video, subscribe to my channel Tutor Ayodele, share the video to your loved ones, and then as you subscribe, turn on the notification button so that anytime I upload new videos you can get notified. Alright, see you in my next video.